All right. Hello. Okay, awesome. Let's go ahead and start. So it looks like we've got not all the participants here yet, but they're gonna keep coming, I guess. So yeah, it's good to have you all here. This is our very first summer Zoom session by Impulse. And as you can see on our website, there's a huge calendar of all the things we're hosting. So some of them are going to be taught by me. I'm Jay, and some of them are going to be taught by Saloni. But yeah, so today's session will go ahead and start. All right. So this is the doctor. Oh, wait, actually, can someone please unmute and tell me if they can see the screen and everything? Maybe Saloni. I don't know, because I can't see the chat right now.
I can't see the screen right now.
I can't see the screen either.
Oh, okay. Hold up. Okay. What about now?
Yes.
Okay. Awesome. So yeah, this is the Doctor Who, Doctor You module. Okay. So what we're gonna cover today is forensic medicine. If I can get this off my screen. And forensic medicine is basically just the like scientific and medical techniques used by people in like the FBI, CIA. I'm not sure about the CIA, but a lot of police work. They use it to figure out like who committed a crime and stuff about the crime scene. So I am Jay talking right now, and the other person in this call is Saloni, and both of us are hosting this thing. And yeah, I mean we're high schoolers at Dulles, so that's pretty much it. Let's just get started. So imagine you walk into a crime scene, all right? There's a bunch of scientists there along with policemen, you know. So there's a bunch of evidence. There's all this stuff like a blood splatter and hair and fingerprints and everything, right? So let's imagine that you're the head detective here, all right? And it's your job to figure out what's going on in this case, what's the crime, who committed the crime, okay? So, some police people there have already interviewed the victim. So, the victim's name is Bob, and he lives in a nice suburban house. He has a wife and two children, so four family members total. And Bob tells us that one day a masked man came into his house, and he was just him in the house, no one else was there. And the masked man stabs him with a knife. All right, so that's bad. He takes money from Bob's safe and he runs away. And luckily, Bob called 911 in time and his life was saved. Everyone is okay. But now it's up to you to find out who the killer is. And not the killer, the criminal, because you're the head detective here, all right? So there's a bunch of different types of evidence that you can find on a crime scene. The first one we're going to talk about here is blood. So, I mean, not like there's a lot of stuff you can figure out from just the blood on a crime scene. So we'll talk about some of that stuff here. So a lot of you may have heard before about blood types. So there are four main types of blood, and this is because there's a certain gene that humans have, which causes them to have different types of blood cells, essentially. So blood type is important in medicine, of course, because if you want to donate blood, your blood type has to match. And there's also like it's pretty important for forensic medicine as well. So if your blood type matches with the blood on a crime scene, that means, you know, either you could have been the victim or you could have committed the crime, you know. So here are the like four main types of blood. You can either have type A blood, you can have type B blood, you can have type AB blood, or type O blood. But this is just a bunch of letters, right? Like, how do we know what the actual difference is between these? So on the surface of cells, in this case blood cells, you're going to have a bunch of things on the surface, which are called antigens. And you can see here, well, we'll go back to the last slide, but all these different things on the surface, we call them antigens. So they're just like little things that stick out of the cell surface. And for blood, you have two different types of antigens. You have the A antigen, which is, well, the yellow one here, and you have the B antigen, which is the blue one here. So you have a bunch of different blood types, but you only have two different types of antigens. So the different blood types are caused by different combinations of these antigens on the surface of red blood cells. If you have type A blood, you have only A antigens right here. As you can see here, this thing has only yellow or A antigens, which are just things sticking out on the surface. Type B blood has only B antigens. So right here, you can see this is type B blood and has only the blue things, all right? Type AB blood has both of these antigens. So it's not on this diagram here, but imagine a red blood cell with yellow and blue things sticking out. So it has yellow triangles on it, and it also has blue lollipops on it, okay? So type AB blood has both of these. And then a very special type is called type O. Well, O is sort of like 0, right? It has nothing. So type O blood is basically just this thing without anything sticking out on the surface, just a regular red blood cell with nothing. So, well, here are the 4 basic types of blood that we talked about. And then you may have also heard doctors say something like AB positive or B negative or something like that. So that's caused by something else called the RH factor. So just to review, you have the cell surface antigens, which are A and B, and then you also have something called the RH factor. So this is, if you have it, then your blood is positive. If you don't have it, then you just call it negative. So if you have O positive, that means, well, the RH factor is just another antigen, like the other things we talked about. But yeah, if you have type O positive, that means you have nothing, you have no blue lollipop, you have no yellow triangle, but you do have something called the RH factor sticking out on the thing. So whenever you like let's talk about the human body's response to something like this first, right? So in the human body, you have a bunch of white blood cells, which are a part of the immune system, right? So these white blood cells, you can think of them like big angry piranhas. And if they see something they don't recognize, like in this case, all the red blood cells here are type A. And then this thing is type B. It doesn't belong here, right? So the human body thinks of this as something foreign. So like your parents may have told you stranger danger. You really don't want strangers, coming into your house or whatever, right? So if you have an antigen that's not like native to your body, then it's going to cause a reaction by the immune system, which means this immune system cell, which is like a white blood cell, is going to eat up this foreign red blood cell. So just to review, like your normal, like your body, it just has a regular single blood type. So like, for example, I don't know my blood type, but let's say I'm A positive. So that's all the red blood cells in my body, which are native to my body, are going to be A positive. And then if you have a foreign red blood cell, so this could be like if someone else, like some random person injected their blood into you, their blood cells would have a totally different type, right? They could have a totally different type. So if my blood type was A and somebody injected B red blood cells into my body, then my immune system would see this B antigen on the surface. It's blue and it doesn't like it because it's a stranger, right? So my immune system would cause a reaction against this, okay? So how exactly does this reaction work, the immune system reaction? So when the body, like when our immune system comes into contact with foreign red blood cells, so just like this, blue red blood cell here, foreign just meaning like it's not your normal blood type, the mechanism by which the immune system acts is, one major mechanism is it sends out antibodies. So antibodies are just, I mean, you may have heard of this before, and like when it comes to vaccines and everything, but antibodies are just pretty much little proteins, okay? So they're just little things that they're really sticky and they bind to things that your body does not want inside it. So if you have a virus, your body is going to send out antibodies to cover that virus. And the main reason why we have antibodies in the case of blood cells is it's going to lead to something called agglutination. It's a big word. You don't really need to worry about that right now, except you can see the word glue here, right? What does glue do? It makes things stick. So what happens when your body comes into contact with a foreign red blood cell is it sends out these antibodies for that foreign red blood cell type. So in this case, you're seeing like a white blood cell trying to eat this foreign red blood cell. But another thing that happens is these other specialized immune cells, they send out antibodies, which are sticky things that stick to this red blood cell. And they only stick to the foreign red blood cell. So what happens is when these things are sent out, they're like shot out into the blood. What happens is all these foreign red blood cells, they stick together. So if you can imagine like a pile of paper clips, right? A pile of paper clips, and then you throw a little magnet into it. So like what happens? All the paper clips stick together, right? So it's easy to get rid of. So that's the same principle here. The antibodies cause everything to stick together, and this forms clumps in the blood. So, I mean, that's a whole different direction we went along, right? So now let's get back to the crime scene and what everything has to do with like forensics. So we take advantage of this natural response in the human body for testing blood types. Because what happens when you have antibodies that go against this certain red blood cell? Everything sticks together and it forms clumps. So we can do the same thing in a test tube as long as we have the right antibodies that stick to that antigen. So usually the way antibodies are named is they're named after the thing that they bind to. So anti-A antibodies. So anti-A antibodies are just going to look like this, like little Y-shaped, things that are sticky. And since they're anti-A, you see this triangle right here? That's what they're going to bind to. So they're just going to stick like this, like the little Y things. They're going to stick to this triangle. And because they're sticky, it's going to make everything clump up. Like you can see here, everything is being clumped up. So anti-A antibodies are just going to bind to type A red blood cells, and they're going to make everything clump up. So this can happen in a test tube, right? So you can see the clumping. So if the blood, like the blood that's in a test tube, has an A antigen, which means it has like the yellow triangles or whatever on its surface, the anti-A antibodies are going to cause clumping when you add that to the test tube. And bear with me, guys. We're going to do a little lab demonstration in a tiny bit so we can see how this all works because it's hard to understand right now probably. And yeah, so what blood types contain an A antigen? We have the A blood type, which is just going to be this yellow triangle all by itself. And then we also have the AB blood type, right? So the AB blood type is going to be both the A antigen and the B antigen. So it's going to look like this yellow triangle thing along with a bunch of blue lollipop stuff on top of it. So it has both of the antigens. So, and the same thing for anti-B antibodies. They cause clumping if the blood has a B antigen on top of its surface. So this can be the B blood type or it can be the AB blood type because the AB also has the B, right? And then one last thing is we have anti-RH antibodies. So it's not in the diagram, but like we said, blood can be either Rh positive or Rh negative, right? Which means there's this extra thing called the Rh factor. If it has it, then it's positive. If it doesn't, then it's negative. So yeah, I mean, that's a lot of information, but these are basically the antibodies that your body produces against red blood cells that are foreign. And scientists basically steal these from the body, like from a rabbit or something. They just take it from the blood, and then they can use this in a procedure that can let you test blood type. Because anti-A antibodies are going to cause clumping if the blood is these types. These antibodies are going to cause clumping if it's these types, and yeah, so on. So yeah, finally back to the crime scene. So Bob tells the police that like while trying to save himself from the masked man, he punched the guy. So that causes a few drops of blood to fall onto the floor. And this is the masked man's blood. So this means that now we have the masked man's blood on the crime scene, like it's on the floor or something. So we can use that to test it, right? So there's two types of blood at the crime scene. Bob's blood, because he was stabbed originally, right? So when he got stabbed, it released some blood onto the floor. And we also have the masked man's blood. So now that we have two blood types, we have to figure out, like, we have to test both of them and figure out which is which, all right? So, like, the police say that the main suspect here, who committed the crime, would be that Bob's neighbor, Ralph. And Ralph has blood type O negative. So now that we have the masked man's blood on the floor, and we can try and test it, what we want to see is if it matches with Ralph's blood type, O negative. So now we have to go to the lab and figure out how we can test the blood type to see if the blood on the crime scene is the same blood type as Ralph's blood type. So yeah, I mean, now we're gonna go do a little virtual lab. So before we begin this, before I send out the link and everything, do we have any questions? Because that was a lot of information, all right? I'll stop sharing just for a moment so I can see the chat. So does anybody have any questions? Just feel free to type it in the chat. All right. So yeah, you can ask questions if you want, but just a little review, all right? So type in the chat the 4 blood types that we talked about. Just click in the chat and type whatever answer you think it is. All right, so whoever answered, it looks like y'all got that down, okay? So now let's do a little test. So let's say my natural blood type is A, okay? A positive. So which antigens do I have on the surface of my red blood cells? So my blood type is A positive, okay? Like A plus, like a test, I guess. So which antigens do I have on my surface, the surface of my red blood cells? So the 2 antigens we talked about are A and B, along with the Rh factor, right? So which of those, you can just say which of them you think I have on my surface. All right, awesome. So since it's A over here, right? I have the A antigen on the surface of my red blood cells. Since there's no B over here, that means I don't have the B antigen. So I only have the A antigen. And then over here it says positive. So since it's positive, that means that I have the Rh factor. That means I'm Rh positive. And yeah, so Arpan asked if we'll send out the PowerPoint at the end. Yeah, we are gonna send out a link to the PowerPoint so all of you can access it afterwards. So yeah, I mean, good job, guys. It seems like a good amount of you responded, and whoever responded, as far as I can see, everyone got it right. So
Yay.
yeah, yay. So now I think we are ready to go do the lab, okay? So if you want to follow along, you can type this into your URL and this URL into your web browser, yes. Actually, I'll copy paste it into the chat. So you can copy paste that into your browser if you want to follow along. But in case you don't have the ability to do it right now, I'll just do it on the screen. I'll screen share and yeah, I'll explain each step as we go. Okay. So okay. Can everyone see my screen?
Yes.
All right, awesome. So let me, I don't want that audio. So I'll see if I can shut that audio off. All right. Everyone can hear me, right?
Yes.
Okay, cool. So what's going on here is this is just like a laboratory setting, and you can ignore this little text here because we're going to go with our own story that we set up. So what's going on here is, if you remember, we have 2 blood types at the crime scene. So we have the blood of Bob, who got stabbed, and that's why we have blood on the ground, Bob's blood. And then we also have the masked man's blood. So what we're going to do here what we're going to do is we're going to test both blood types. And the reason we're going to do that is because we have a suspect already, right? We have a suspect, Ralph, and Ralph is Bob's neighbor. And we think that Ralph might be the criminal. And we know that Ralph's blood type is O minus. So now what we're going to see is we have Bob's blood already, and we have the masked man's blood. So if Bob's blood is B positive and the masked man's blood is O negative, that means the masked man could be Ralph, because Ralph also has O negative blood. So we'll rehash that at a later time. So now let's just see what the lab looks like. So here we have anti-A serum. A serum is just a liquid which has antibodies inside it, okay? So if you remember earlier, we talked about the anti-A antibodies. So anti-A antibodies bind to A antigens, which makes sense, right? So if we add this anti-A antibodies to a sample of blood that has the A antigen, what's going to happen is that blood is going to clump up, okay? And same thing for anti-B antibodies. So anti-B antibodies, if they're going to bind to B antigens on red blood cells, and if that blood has B antigens, so it's either type B or it's type AB, then that means that it's going to cause the blood to clump up. And finally, we have anti-RH antibodies. So if the blood is positive, like it's A positive, B positive, AB positive, or O positive, whatever it is, as long as it's positive, it's going to cause the blood to clump up, okay? So, well, these aren't really that important. We're just going to use those in our investigation. Okay, so here we're going to test the first and the second blood sample, because those are the two that we found at the crime, all right? Just ignore the third and the fourth. We're just going to look at only the first and the second. And then this is just like a trash can. And then, yeah. Here are the slides that we're going to use. So slide is just a container that we're going to use to hold the blood. Okay. So now it's time for us to open our lab notebook. All right. And it's we have to predict when it's going to clump and when it's not going to clump. So now it would be great if some of y'all could unmute and tell me your predictions. All right. Because I can't see the chat right now. So if you type it, I can't see it. But if you say it out loud, then I can hear it. All right. So let's just start off. And if you have the answer, don't hesitate. Just unmute and say what you think it is. All right. Because I can't do this without your help. So let's say if my blood type is A, like if the blood in the test tube is blood type A, if I add anti-A antibody, is it going to clump or is it not going to clump? Yes or no? Can anyone unmute and tell me?
Yes.
Yes. Okay, so does anyone else have an answer?
Yes.
Yes.
All right, awesome. So it looks like we got several who say yes, it is going to clump. And that is right. So what if I have blood type A, so I only have A antigens on my cell surface, and I add anti-B antibody? Is it going to clump? Yes or no?
No.
No. No.
That's correct. So, I mean, yeah, we want to go a bit quickly. So I'll fill out this column for you. So if you have blood type B and you have anti-A antibody, no, it's not going to clump. And if it's blood type B and you have anti-B antibody, yes, it is going to clump. So now let's do this one as a group, okay? So if it's blood type AB and I add anti-A antibody, is it going to clump? Yes or no?
Yes.
Yes.
Yes. So what about anti-B antibody?
Yes.
Nice job, guys. Okay, finally, we just have a few more left. So can you tell me this one? If it's blood type O?
No.
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 No. And what about this one? Anti-B?
No.
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 So if it's blood type O, that means it has nothing on its surface, right? So it's never going to clump for anti-A or anti-B. And now we just have Rh positive or Rh negative. So for Rh positive, if I add anti-Rh antibody, so the antibody that binds to Rh, is it going to clump? Yes or no?
Yes.
Yes. So if it's Rh positive, it has Rh on its surface. So the anti-Rh antibody is going to bind to that, and it's going to clump up. And if it has no Rh, then there's nothing for this thing to bind to, so there's going to be no clumping. There we go. So good predictions, guys. So now we're going to take this, and we're going to fill up the first blood sample that we found on the scene. So we just put it in this little slide here, all right? And then, now let's add each of the things to see which ones clump up. So this is the same blood in all three wells, all right? We're just gonna add the antibody. We're gonna add different antibodies to the same blood sample to see how it works. Okay, and then now finally this one. So you can see it's the same blood sample, but we added 3 different antibodies, okay? And now, let's set the timer, and after 30 seconds, let's see what happened here. So, does this look like clumping to y'all? Because it does to me. So, let's see if we can type our responses here. So, blood sample 1, does it clump in response to the anti-A antibody? What does it look like?
No.
No, right? It's just smooth. It's just regular. And then, but it becomes all weird looking for B and RH. So it does clump in response to anti-B antibodies, and it does clump in response to anti-RH antibodies. So now let's test the second sample. So again, what we're going to do is we're going to put this blood, the second blood that we found on the crime scene, and we're going to add the same blood to all 3 of these. And now we're going to add anti-A antibody to one of these. We're going to add anti-B antibody to one of these. And we're going to add anti-RH antibody to one of these. So now, yeah. All right. So, okay, so we set the timer, and it's been 30 seconds. And now let's look at this. So it doesn't look like the first one. The first one was all clumped up in some of them. But for this one, it looks like none of them have clumped. So no, it didn't clump for anti-A antibodies. No, it didn't clump for anti-B antibodies. And no, it did not clump for anti-RH antibodies. So now these are the 2 blood samples that we found on the crime scene, all right? So one of them is Bob's blood type, and one of them is the masked man's blood type, because both of their blood is on the crime scene. So now what we're going to do is we're going to try to guess the blood type. Well, we're not going to guess. We're going to figure it out. We're going to figure out the blood type for each of these blood samples. So let's look at the first one, blood sample 1. Okay? So we're going to need to do this as a group again, all right? So it doesn't clump in response to anti-A. So that means, does it have the A antigen, or does it not have the A antigen?
It doesn't.
That's correct. It does not have the A antigen. But for this one, it does clump in response to anti-B antigen. So it does have that. Okay? So its blood type is going to be a B. And then is it B positive or B negative? Let's see here. It does clump in response to anti-RH. So if it does clump in response to anti-RH antibodies, then is it going to be positive or is it going to be negative?
Positive.
Exactly. It's going to be positive. So can anyone tell me what the blood type for blood sample 1 is?
B positive.
B positive.
Are you telling me to be positive? Wow, that's a positive message. So blood sample 1 is going to be B positive. So that's going to be one of the people's blood type. And then can anyone tell me what the blood type for blood sample 2 is?
O negative.
All right. So one person thinks it's O negative. Anyone else?
O negative.
O negative.
All right. So we got 3 people who think it's O negative, and that is right. It has no A antigens, no B antigens, and it's negative because it doesn't have the RH. So all 3 of these are going to be negative. So that's O negative blood. And who else has O negative blood? If you go back to this, we'll see that the prime suspect, Bob's neighbor Ralph, has blood type O negative. So it seems like Ralph is a prime suspect for here, all right? And Bob's blood type is B positive. So that's the person who came to the police. He's the victim. So we can ignore that one because that's his blood. And then Ralph's blood type is O negative. So Ralph is a prime suspect here, all right? And so what we're going to do now, guys, or we still have some more stuff for y'all, but we have to take a break for like probably 1 or 2 minutes. And we'll have you join back in like 2 minutes, okay? So I'll end the call now. Like everyone is going to be kicked out. And then using the same link, y'all join back after 2 minutes, all right? All right.